China just finished building something that sounds like science fiction. Not a skyscraper, not a bridge. A machine so large it's visible from space, so complex it required inventing entirely new branches of engineering to make it work, and so strategically important that 3 U.S. intelligence agencies have entire divisions dedicated to tracking its progress. The machine is called the Karst Tunnel Boring System. And what it's designed to do: bore through 300 miles of solid limestone mountain to create the world's largest underground water transfer network, is about to solve a problem that every expert said was unsolvable. Because this isn't just about moving water. It's about what happens when a country decides that geography is negotiable and proves it with a machine that rewrites the physical limits of what engineering can do. Here's the problem China is solving. Northern China has 45% of the country's population and 65% of its farmland. It has 20% of the country's water. Southern China has the opposite problem: abundant water, but less agricultural land and fewer people. For decades, this imbalance has been managed through rationing, groundwater depletion, and accepting that northern cities like Beijing would face chronic water shortages. Then China decided to stop accepting it. The solution is called the South-North Water Transfer Project. It's the largest water infrastructure project in human history. 3 massive canal systems, eastern, central, and western routes, designed to move 45 billion cubic meters of water per year from the Yangtze River Basin in the south to the Yellow River Basin in the north. The eastern and central routes are already operational. They use a combination of canals, pipelines, and pumping stations. They work, but they're limited by terrain. The western route, the final and most ambitious piece, has to cross the Tibetan Plateau, a region with an average elevation of 14,000 feet, mountain ranges that reach over 20,000 feet, and geology so complex that conventional tunneling methods simply don't work. So China built a machine that does. Hit that like button and subscribe right now, because what I'm about to show you isn't just the largest engineering project on Earth. It's a preview of what infrastructure looks like when a country stops asking, "Can we do this?" and starts asking, "How fast can we do this?" But here's the part that should genuinely concern every Western infrastructure planner. The technology that makes this possible didn't exist 5 years ago. China invented it. And the implications go far beyond water. Because if you can bore through 300 miles of mountain, you can bore through anything. And that changes the strategic map of the entire planet. What the Karst Tunnel Boring System actually is. Traditional tunnel boring machines, TBMs, work by grinding through rock with a rotating cutting head covered in disc cutters. They're effective in uniform geology, granite, sandstone, clay, but they fail catastrophically in karst terrain. Karst is limestone that's been dissolved by groundwater over millions of years, creating a chaotic underground landscape of caves, voids, underground rivers, and pockets of water under extreme pressure. When a conventional TBM hits a void, the cutting head can drop suddenly, damaging the machine. When it hits pressurized water, the tunnel can flood in minutes. Karst terrain is why the western route of the South-North Water Transfer Project was considered impossible for decades. The Karst TBM solves this with 3 breakthrough technologies. 1. Ground-penetrating radar array. The machine has a radar system mounted 50 meters ahead of the cutting head that maps the geology in real time. It can detect voids as small as 2 meters in diameter up to 100 meters ahead. When it finds one, the machine stops, and a crew injects grout to stabilize the area before continuing. This turns tunneling from a blind process into a mapped one. 2. Variable pressure control. The cutting head operates inside a pressurized chamber that can adjust in real time to match the water pressure in the surrounding rock. If the machine encounters a high-pressure aquifer, the chamber pressure increases to prevent flooding. If it hits a void, the pressure drops to prevent collapse. This system adjusts hundreds of times per day, automatically, based on sensor data. 3. Modular cutting head. The cutting head is made of replaceable segments that can be swapped out without stopping the machine. In karst terrain, cutters wear out unpredictably, sometimes after 50 meters, sometimes after 500. A conventional TBM has to stop for days to replace cutters. The karst TBM replaces them in hours while continuing to bore. The scale. The machine is 18 meters in diameter. That's tall enough to fit a 5-story building inside the tunnel it creates. It weighs 4,500 tons, roughly the weight of 30 fully loaded Boeing 747s. And it's not one machine. It's a fleet of 12, operating simultaneously on different sections of the Western route. Each machine costs approximately $85 million. The entire fleet represents over $1 billion in specialized equipment that didn't exist until China built it specifically for this project. The analogy: surgery while running. Think of the Cars TBM like a surgeon performing an operation on a patient who's running a marathon. The patient, the mountain, is unstable, unpredictable, and constantly changing. The surgeon, the machine, has to adapt in real time, make decisions in seconds, and never stop moving forward. One mistake, hitting a pressurized aquifer without adjusting chamber pressure, or dropping into a void without stabilizing it first, and the entire operation fails. That's what this machine does, 24 hours a day, for years at a time. And it's working. So how far along is this project? Because the construction timeline is where this stops being impressive and starts being genuinely alarming to anyone who's ever tried to build infrastructure in the West. The impossible schedule. The western route of the South-North Water Transfer Project was officially approved in 2020. The first Cars TBM began boring in 2022. As of August 2024, the fleet has completed 127 kilometers of tunnel, roughly 79 miles, through some of the most geologically challenging terrain on Earth. For context, the Gotthard Base Tunnel in Switzerland, currently the world's longest railway tunnel at 57 kilometers, took 17 years to complete. China has bored more than twice that distance in 2 years. And they're not done. The target completion date for the western route is 2030. That's a 300-mile tunnel system through the Tibetan Plateau in 10 years. Western engineers said it couldn't be done in 30 years. China is doing it in 10. How they're moving this fast? The speed comes from 3 factors. 1. Parallel construction. Instead of boring one tunnel from end to end, China is boring from 12 different access points simultaneously. Each TBM works on a separate section. When they meet in the middle, the sections connect. This is standard practice for long tunnels, but China is doing it at a scale never attempted before. 2. 24/7 operation. The machines never stop. Crews work in rotating shifts. Maintenance happens while the machine is boring, not during scheduled downtime. In conventional tunneling projects, machines operate 40 to 50% of the time. The Cars TBMs operate 85% of the time. 3. Vertical integration. China isn't buying components from global suppliers. They're manufacturing everything domestically. The cutting heads, the hydraulic systems, the sensors, the control software. When a part fails, a replacement is fabricated in a factory in Chengdu and delivered to the tunnel site within 48 hours. No international shipping. No supply chain delays. This is the same strategy China used for high-speed rail, expressways, and semiconductor equipment. And it's working again. The human cost nobody talks about. Here's the part that doesn't make it into the official press releases. Tunneling through Cars terrain is extraordinarily dangerous. Since 2022, there have been at least 14 confirmed fatalities on the Western Route project. Flooding incidents, rockfalls, equipment failures. The Chinese government doesn't publish comprehensive safety data, but independent analysis suggests the fatality rate is approximately 3 deaths per 10 kilometers of tunnel, roughly 10 times higher than comparable projects in Europe or North America. Western projects would shut down after a single fatality for safety reviews. Chinese projects pause for 24 hours, implement procedural changes, and resume. The calculus is different. The timeline is non-negotiable, and the workers know it. The water crisis. Northern China's water shortage is not a future problem. It's a current crisis. Beijing's per capita water availability is 100 cubic meters per year. The UN defines water scarcity as anything below 1,000 cubic meters per year. Beijing is at 10% of the scarcity threshold. The city survives through groundwater extraction, which is depleting aquifers faster than they can recharge. Parts of Beijing are sinking at a rate of 11 centimeters per year due to subsidence from groundwater depletion. That's not sustainable. It's not even stable. The South-North Water Transfer Project is designed to deliver 12 billion cubic meters of water per year to Beijing and the surrounding region. That's enough to stabilize groundwater levels, support continued urban growth, and ensure agricultural production in the North China Plain, the region that produces 50% of China's wheat and 33% of its corn.
Without this water, Northern China faces a choice:
depopulate,
deindustrialize,
or collapse.
The Western route makes a fourth option possible:
continue growing.
The engineering elegance. Here's what makes the Western
route brilliant. It uses gravity.
The Yangtze River headwaters in the Tibetan Plateau are at a higher elevation than the
Yellow River Basin in the north.
Once the water enters the tunnel system,
it flows downhill naturally.
No pumping required.
No energy
cost.
The eastern and central routes require massive pumping stations to lift water over terrain obstacles. The western route is a 300-mile downhill pipe. The only energy cost is maintenance and monitoring. Over the 50-year operational lifespan of the project, that saves an estimated $40 billion in electricity costs. This is why the Western route, despite being the most difficult to build, is the most economically viable in the long term. The geopolitical leverage. The Western route doesn't just move water within China. It passes through regions that are upstream of major rivers flowing into India, Pakistan, and Southeast Asia. The Brahmaputra, the Mekong, the Salween, all of them originate in the Tibetan Plateau. China has repeatedly stated that the South-North Water Transfer Project will not divert water from international rivers. But the infrastructure to do so is now in place. If China ever decided to restrict water flow to downstream countries, the Western route gives them the physical capability to do it. That's not a threat. It's leverage. And every country downstream knows it. If you're starting to realize this isn't just about water infrastructure, you're exactly right. Hit that subscribe button. Because what I'm about to show you is how this same tunneling technology is being adapted for military use, high-speed rail, and a project that could literally change the climate of Central Asia. Military applications. The karst TBM technology is dual use. The same machines boring water tunnels can bore military tunnels, underground command centers, missile silos, submarine bases, logistics networks that are invisible to satellite surveillance. China has been expanding its underground military infrastructure for decades, but the pace has accelerated dramatically since 2022. The same year the karst TBMs came online. U.S. intelligence estimates that China has bored over 5,000 kilometers of military tunnels in the last 2 years. That's more than the entire U.S. interstate highway system was in 1960. These tunnels are deep, some over 1,000 meters underground, which makes them effectively immune to conventional weapons. Even bunker buster bombs can't reach them. The only way to destroy a target that deep is a nuclear strike, and that changes the calculus of any potential conflict. The high-speed rail expansion. China's high-speed rail network is already the largest in the world at 45,000 kilometers. But large sections of Western China, Xinjiang, Shanghai, Tibet, remain unconnected because the terrain is too difficult for conventional rail construction. The karst TBM changes that. China is now planning high-speed rail tunnels through the Himalayas, connecting Tibet to Sichuan and Yunnan. The tunnels will be over 100 kilometers long, at elevations above 4,000 meters, through geology that would have been impossible to tunnel through a decade ago. If completed, these rail lines will cut travel time from Beijing to Lhasa from 40 hours to 12 hours. They'll integrate Tibet into the national economy in a way that roads never could. And they'll make it logistically feasible to move military forces to the Indian border in hours instead of days. The Central Asia Water Project. Here's the one that sounds like science fiction. China is exploring a tunnel system to divert water from Siberian rivers into the Darien Basin in Xinjiang. The Darien Basin is one of the driest places on Earth, a desert larger than California. But it sits on top of massive oil and gas reserves that China wants to exploit. The problem is water. You can't run industrial operations in a desert without water. The solution: or a 2,000-kilometer tunnel from the Ob River in Siberia to Xinjiang. The tunnel would deliver 20 billion cubic meters of water per year, enough to support agriculture, industry, and a population of 50 million people in a region that's currently uninhabitable. Russia has tentatively agreed to the project in principle. The engineering is feasible with karst TBM technology. And if it happens,
it would be the largest infrastructure project in human history, dwarfing even the South-North Water Transfer Project. It would also give China control over the water supply of Central Asia, which is currently dependent on rivers that originate in the Himalayas and Siberia. That's not just economic leverage. That's existential leverage. The regulatory impossibility. Imagine trying to build the Western route in the United States. You'd need environmental impact statements for every section of tunnel, consultation with every Native American tribe whose ancestral lands the tunnel passes under. The Army Corps of Engineers, and state environmental agencies in every state the tunnel crosses, public comment period, legal challenges, and judicial review at every stage. The permitting process alone would take 15 to 20 years.
And judicial review at every stage.
Construction would take another 20.
Permitting process alone would take 15 to 20 years.
35 to 40
Construction would take another 20.
And that's if nothing goes wrong.
35 to 40
China
years.
completed the environmental review for the Western route in 18 months.
China completed the environmental review for the Western route in 18 months.
There were no
Construction
public comment
began
periods.
immediately. There were no public comment periods. No legal challenges. No judicial review.
The project was declared a national priority, and everything else became secondary. That's not a criticism.
It's an observation. Democratic systems prioritize process and consent. Authoritarian systems prioritize outcomes and speed. And when it comes to infrastructure, speed wins. The cost structure. The Western route is projected to cost $62 billion over 10 years. That's $6.2 billion per year. For context, California's high-speed rail project, which will connect Los Angeles to San Francisco, a distance of 380 miles, is currently projected to cost $128 billion and won't be completed until at least 2033.
China is building a 300-mile tunnel through the Tibetan Plateau for half the cost of a rail line through the Central Valley. The cost difference isn't about labor or materials. It's about process. Every delay, every legal challenge, every redesign adds cost. China eliminates delays by eliminating the processes that cause them. The political will. Here's the most important difference. China treats infrastructure as a strategic priority. The U.S. treats it as a budget line item. When China decides to build something, the money appears, the workers are mobilized, and the project happens. When the U.S. decides to build something, it gets debated, defunded, redesigned, and delayed until the political coalition that supported it falls apart. The Western route has survived three changes in Chinese leadership. It survived a global pandemic. It survived economic downturns. Because it's not a political project. It's a survival project.
And survival projects don't get canceled. The infrastructure gap. China is currently outspending the U.S. on infrastructure by a ratio of roughly 8 to 1 as a percentage of GDP. That gap is widening. And the gap isn't just about money. It's about capability. China can build things the U.S. can't build, at speeds the U.S. can't match, at costs the U.S. can't compete with. That's not a temporary advantage. That's a structural one. And it compounds. Every completed project teaches Chinese engineers something new. Every new technology gets applied to the next project. The learning curve is steep, and China is climbing it faster than anyone else. The geopolitical realignment. Infrastructure is power. Roads, tunnels, and pipelines determine where goods move, and where economic activity concentrates. China is using infrastructure to reshape the geography of Asia in ways that favor Chinese interests. The Belt and Road Initiative is the most visible example, but the domestic projects, like the South-North Water Transfer, are just as important. They make previously uninhabitable regions viable. They connect previously isolated populations to the national economy. They turn geographic disadvantages into strategic assets. The U.S. built the interstate highway system in the 1950s and 60s, and it defined American economic geography for the next 50 years. China is doing the same thing now at a larger scale with more advanced technology. And the geography they're creating will define the 21st century. The climate wildcard. Here's the part nobody's talking about. If China successfully diverts water from Siberia to Xinjiang, it could change the climate of Central Asia. More water means more vegetation. More vegetation means more rainfall. More rainfall means more agriculture. You're not just moving water. You're terraforming a desert. The ecological consequences are unpredictable. The geopolitical consequences are enormous. And the fact that
geopolitical
China is
consequences are
seriously
enormous.
considering this and has
And
the
fact that
technology
China is
to
seriously
attempt
considering
it should
this
tell you
and has the
everything you
technology
need
to
to know
attempt it
about the scale
should
of
tell you
ambition
everything
we're
you need to
dealing
know
with.
about the scale of
What
ambition
China
we're
is
dealing
building
with.
today isn't just impressive.
What China is
It's a
building today
preview
isn't
of what's
just impressive.
possible when a country decides
It's a
that the
preview of
physical
what's
world
possible
is
when a country
negotiable
decides that
and
the
commits
physical
the
world is
resources to
negotiable and
prove
commits
it.
the resources
The
to
karst
prove
tunnel
it.
boring system isn't the
The
story.
karst tunnel
It's the
boring
tool.
system isn't
The
the story.
story is what happens when you
It's the
use that
tool.
tool to move water,
The story
build
is what
rail
happens
lines,
when you use that
create
tool to move
military
water, build rail
infrastructure,
lines,
and
create
reshape
military
the geography
infrastructure,
of
and
an
reshape
entire
the
continent.
geography of an
The
entire
West
continent.
spent the last 30 years
The
optimizing
West spent the last
financial
30 years
systems.
optimizing
China
financial
spent the
systems.
last 30 years optimizing
China spent the
physical
last 30
systems.
years
And in
optimizing
the long
physical
run,
systems.
physics wins.
And in the
If
long
this
run,
changed how you
physics
see
wins.
the infrastructure gap
If
between
this changed
China
how you see
and
the
the West,
infrastructure gap
smash
between
that
China
like
and the West,
button and
smash
subscribe
that like
so you
button and
never miss what
subscribe so
comes
you never
next.
miss what comes next.
Now I want to hear from you. Is
Now I want
China's
to hear from you.
infrastructure
Is
advantage
China's
permanent,
infrastructure
or can the
advantage
West catch
permanent?
up if
Or
it
can the West
decides to
catch up if it
prioritize
decides
it?
to prioritize
Drop
it?
your answer in the comments.
Drop
Because
your
I have a
answer in the
feeling
comments
this one's
because
going
I
to
have
be
a feeling this
contentious.
one's going to